Hello all, this is Mr. G, and this is our objective. We're doing Chapter 3, Section 4, and today we are going to practice linear programming. Today's going to be more of an independent day. So I'm going to give you 3 problems. I want you to try them, but the rest of this video is going to be me going through those 3 problems in case you need to come back and check your answer. You need help with a step, help with a step or anything like that. I want this here for you. So here's example 1. It says a manufacturer of ski clothing masks makes ski pants and ski jackets. Okay, so it looks like we're comparing pants and jackets. So I'm going to start making my table as I read. We got pants and jackets. All right. The profit on a pair of ski pants is $5. Now, profit's probably what we're maximizing. Yeah, we're going to maximize profit. So I'm going to put profit at the end of this table. Profit's what we want to maximize. The profit on a pair of ski pants is $5. And the jacket is $11. All right. Both pants and jackets require the work of sewing operators and fabric cutters. Okay, so those look like the 2 things that we're going to have limited amounts of, sewing operators and fabric cutters. So we'll put this amount of time we have sewing and the amount of time we have to cut the fabric. There are 64 minutes of sewing operator time. So that's one of our constraints. That's sort of the maximum amount of sewing time we have. 56 minutes of fabric cut time available, so that's the constraint on the amount of time we have to cut. Takes 8 minutes to sew 1 pair of ski pants. Sewing 8 minutes pants. I'm losing track of where I am. There we go. And 4 minutes to sew 1 jacket. And fabric cutting takes 4 minutes on pants and 8 minutes on a jacket. So find the maximum profit and the amount of pants and jackets to maximize that profit. All right, now we're ready for our linear program. So the objective function, we're trying to maximize profit, so that would be 5x plus 11y. We'll make the pants x and the jackets y's here. Now, I'm going to put a box around this because that's what we're going to come back to at the very end of the problem. Now we need our constraints. The first limitation, let's do the amount of time we have for sewing. So that would be 8x plus 4y is less than or equal to 64, because 64 is the limiting factor. That's the constraint we have on the amount of time we can spend sewing, or sewing time, or fabric sewing operator time, whatever they called it. Let's just get y by itself. Take away 8x, so we get 4y is less than or equal to negative 8x. That's a bad x, that's a little better. Plus 64. Divide everything by 4. And we get, let's see, y is less than or equal to negative 2x plus 4 goes into 64 once with 2 left over, 16. 4 times 16, that'd be 40 and 24. Yeah, that checks out. Now, right away, let's put this into our graphing calculator. So it's negative 2x plus 16. All right. Now, let's get our second constraint. So we'll draw a line right here. The second constraint is going to be the amount of time we have for fabric cutting. So that's 4x plus 8y. 4x plus 8y is less than or equal to, was it 56? Yeah, 56. Get y by itself. So let's see, take away 4x. We end up with 8y is less than or equal to negative 4x plus 56. Divide by 8. Let's see, we get y less than or equal to negative 1/2 x plus 7. Plug that right into our graphing calculator. So it's negative 1 divided by 2x plus 7. And we graph. So there's our feasible region. Remember, it's y is less than for both of them, so we're shading below. So it's going to look like that quadrilateral. I know my drawing's not perfect, but hopefully you can sort of see what we're looking for. All right, now we're going to find our vertices, all except 0, 0. We know 0, 0 is not going to provide the maximum amount of profit. So let's see. That is going to be a y-intercept. Well, let's see. What was the smallest y-intercept? It was 16 and 7, so this should be 0, 7. If you need a review, let me draw a line. Separate that. If we need a review of how to do that, we just hit second table, look at where x equals 0, and that gives us the 2 y-intercepts. Since we shaded below for both of them, we picked a smaller y-intercept. Next, we have this point right here, which is an intersection. Second, calculate 5 for intersect. Go to the right until we see our cursor. There it is. That's close enough. Enter, enter, enter. Intersection, what does it say? 6, 4. 6, 4. And then this last vertex right there is a real root, also known as an x-intercept, also known as a zero. So second, calculate the number 2 for 0. Now let's make sure we're on the right graph. We are on the right function, I should say. So enter for left bound, move to the right of our real root, pass in the x-axis, hit enter again, one more time because we don't care about guessing, and it gives us the real root of 8, 0. 8, 0. Now we just take these numbers, take these points, then plug them into our objective function and see which one gives us the maximum amount of profit. So let's see, we're plugging them into 5x plus 11y. So this first point, 0, 7, that's going to be 0 times 5 is obviously 0, plus 11 times 7 is 77. So that would be $77 profit. 6, 4, we plug that in, that'd be 6 times 5 is 30. I'm going to show a little work here. Plus, where am I? 4 times 11 is 44. So that's going to give us $74 profit. And then plugging in 8, 0, 8 times 5 is 40. And 11 times 0 is just 0. So the maximum profit we can make is actually $77. So let's put a dollar sign right there. So that's selling 0, 7. So 0, our X was the pants. So that's no pants, just making 7 jackets. So this company should focus all their time just making ski jackets to get the most amount of profit. So the answer here, let's remember what the question was. Find the maximum amount of profit, $77. And the amount of pants and jackets, no pants, 7 jackets. All right, moving on to example 2. So again, as we're reading through this, I'm going to make the chart just to save us a little time. So we're screen printing t-shirts and sweatshirts. So those are the two things we're dealing with. T-shirts, scroll down a little bit. We got t-shirts and sweatshirts. So T's and sweatshirts. We'll just abbreviate sweatshirts, SS. Let's see, a t-shirt takes 10 minutes to color. Okay, so it takes a certain amount of time to color. T-shirts take 10 minutes to color. Okay, so we got supply costs. So supplies is $4 per t-shirt and makes a profit of $6. Again, and we're trying to maximize profit. You don't have to have like what you're maximizing at the end. I just sort of a preference. I already forgot the number. This is why I shouldn't talk while I'm reading. $6 profit. Okay. All right, now we go to the sweatshirt. So it takes 30 minutes to color. Costs $20 for supplies. And makes a $20 profit. Now we get to the constraint. So it says you have at most 20 hours to make shirts. 20 hours. Wasn't this in minutes? Yeah, 10 minutes to color, 30 minutes to color. So we want to change that 20 hours into minutes. So that would just be 20 times 60. That's going to be 2 zeros and 12. 1,200? Yeah, 1,200. What's the other constraint? Because I'm sure we don't have $1 million for supplies. And can spend no more than $600 on supplies. So that's our second constraint, our second limiting factor. How many t-shirts and sweatshirts should you color to maximize your profit? So here they're not actually asking us what's the maximum amount of profit. They're saying how many of each. So we have to sort of adjust our answer a little bit. But now we're ready for our linear programming process. We go to the objective function. So our profit is going to be 6x plus 20y. Now, if you ever switch what's x and what's y, our work will look different, but the final answer should be the same. So just keep that in mind. Again, I'm going to put this in a red box to remind us that that's what we have to return to at the very end of this problem to figure out what gives us the maximum. Now it's time for our constraints. First, let's look at the time constraint, which is this 1,200, 10, and the 30. So it's 10x plus 30y, so essentially 10 per t-shirt plus 30 per sweatshirt. That's got to be less than or equal to 1,200. Then we solve, get y by itself, so take away 10x. If you're good enough to skip some of these steps, that's a good thing. I'm just showing all my work here. So 30y is less than or equal to negative 10x plus 1,200. Divide everything by 30. And we get y is less than or equal to negative 1/3 x plus, cross out that 0, and we get 40, if I'm not mistaken. Yeah, 40. Let's go right into y equals. So clear. Get them out of there. So it's negative 1/3 x plus 40. X plus 40. Let's knock out the x because we've got our second constraint to worry about. We just did, that was the amount of time, right? Oh yeah, the amount of time it took to color. Now we've got our supplies, which is 4x, 20y, so 4x plus 20y is less than or equal to 600. less than or equal to 600. Let me check that one more time. 420,600, 420,600. Beautiful. Get y by itself. Take away 4x. Get 20y is less than or equal to negative 4x plus 600. Then we divide everything by 20. Distribute that division to the right side of our inequality. 20's cancel out. We get y is less than or equal to negative 1 over 5x plus, let's see, we cross out that 0, 30. Type that in. So go down to y2. Negative 1 over 5x plus 30. Now we're ready to graph. And we see nothing. There's nothing on the calculator, which honestly shouldn't surprise us if we're thinking about what we're entering in. Look at our y-intercepts. We got a 30 and a 40. These are way, way off of our window. So let's zoom out. I'm going to hit zoom, go to zoom out. We can just zoom out around the origin. That's probably okay. Oh, we still can't see everything. I'm going to zoom out one more time. Zoom out. And this time I'm going to move my cursor, like where we're going to zoom out. I'm going to move that more to the center of quadrant 1, because we don't really care about any of the quadrants with negatives in it. Sorry about that. Too much talking today. That's still kind of ugly. So let me try and zoom in, but adjust where we're zooming in. Let's zoom in. Let's see how this looks. That looks better. That looks better. I'm actually not sure if I like that. So I'm going to go back to zoom out just so we can see sort of what we're looking at. And it's just sort of playing with the window, trying to get it to what we want it to be. So we're going to have a similar feasible region, that we usually do. It's going to look something like that. Because we can see the two lines are crossing each other in that first quadrant. Well, we know this point's going to be one of the y-intercepts. It's going to be the smaller one since we shaded below each. It's 30 and 40. So it's just 0, 30. And again, you can hit second table if you want to see a table for that. The intersection, isn't that bad? Second, calculate intersect. That's pretty close. Enter, enter, enter. 7515. 7515. And then for the real root, here I'm going to want to zoom in again because it's kind of tough to see exactly which, how do I want to say this? It's tough to see where our cursor is on which graph because they're both, we're zoomed out so much, it's just tough to see. So let's zoom in, and I really want to focus on this real root. So I'm going to move my cursor over to where they're crossing the x-axis. Let's hit enter, and let's see what we're looking at. Yeah, there we go. So we want the closer real root. We want the smaller real root. So second, calculate 0, and we are on the correct function. Enter for left bound because we were already on the left of the x-intercept. Hit right till we cross the x-axis, hit enter, and enter again, and we got 120 and 0. So 120 and 0. Now we're ready to take these values from the feasible region, plug them in, and see which one maximizes our profit, right? Yeah, maximizing profit. So let's see, 0, 30, that would be, let me get my red pen, 6 times 0 is 0, 20 times 30, that's 600. Did I do it correct in my head? 6 and 2 zeros, yep, 600. Then 75 times 6, that's 450. Okay, so that's 450 plus 15 times 20, that's just 600 again, right? Oh, 300. Wow, that was bad. Wait, is the other one 600? Now I'm getting worried. 30 times 20? Yeah, I got that one right. Why did I get that so wrong? Unfair. So then we just add those together and get 750. And then 120, 0, that's just 120 times 6. The 20 times 0 just becomes 0, and we get 720. Now, we can see that our maximum value is the $750, but they were asking us the maximum value. They were asking us how many t-shirts and sweatshirts. So our answer is right here. We should make 75x was t-shirts. Yep, 75 t-shirts and 15 sweatshirts to get the most profit possible in this situation. So that's our answer. Last one to go, example 3. So Stan works 2 part-time jobs while he is going through school. He works as a waiter and mows lawns for his neighbors. Okay, so we got the 2 things we're comparing right away. So we got waiting tables, being a waiter, and a mower, yard work. Where was I? The total amount of time he spends working can be no more than 25 hours per week. All right, so the amount of time he's working has to be less than 24. So I guess we got time. Um, 25 is the constraint. Okay, the constraint on both of them. The time he spends working as a waiter each week needs to be between 6 and 12 hours. All right, that's kind of weird. It needs to be between 6 and 12 hours. I guess we can put that right here. So why did that happen? Whatever. So basically, we'll make this x. So this is saying x this time has to be between 6 and 12. All right. And then it moves on to saying he makes $12 an hour for waiting tables. And lost my place again. 6 and 12. $10 an hour mowing lawns. Sorry about that. Lost where I was. How many hours a week should Stan spend at each job to earn the most money possible? All right, so this chart looks very different than we're used to because we've only got time and his salary, like the amount of money he's making. Obviously, these are simple numbers. If you're making, just $10 an hour at a job, you probably look for a job that's more lucrative, you could say. But simple numbers, just because we're doing sort of simple, basic linear programming problems right now. Obviously, not nearly as complicated as it would be in an actual real world situation. But we're getting there. We're getting there. All right. Well, we know the maximum amount of time is 25, so we can do x plus y must be less than or equal to 25 because we added the amount of time waiting tables plus the amount of time mowing lawns. That's got to be less than or equal to 25. And it's saying if he's waiting tables, it has to be between 6 and 12. So I'm going to write that like this. So x has to be greater than or equal to 6, or it has to be less than or equal to 12. So these constraints look a little bit different than we're used to. Oh, I completely skipped the objective function. I'm doing this all out of order. So we use S for salary. I'm trying to keep this color coded. So his salary is going to be 12x plus 10y. I got so caught up in the constraints being different that I forgot the objective function. All right, so now let's graph our constraints. Let me get a little bit more space. Tell you what, let me slide these down to get y by itself. So we take away x, and we get y is less than or equal to negative x plus 25. Let's graph it. Of course, my calculator just went to sleep. Turn it on, please. Y equals, clear that, clear that, clear it, please. So it's negative x plus 25, graph it. Oh, hang on. So I'm going to stop this from graphing by hitting on. Then I'm going to hit zoom 6 to get back to a standard window. But now that I've done that, I realize plus 25 is probably too big. So we're going to zoom out, zoom out, hit enter. And there we go. Now these other two constraints, we actually cannot graph on our graphing calculator because our graphing calculator likes y equals, not x equals. So we're going to have to be creative and make sure we understand what's going on here. So here I'm actually going to draw not the full graph, but quadrant 1. So we've got, what is this? Y is less than or equal to negative x plus 25. That's doing this. That's that line we see on our graphing calculator. Again, it's kind of tough for me to draw on the actual graph. And we're shading below that, so the shading's below. But then it's saying x is greater than or equal to 6, and x is less than or equal to 12. So the graph then, I'll do them in a different color, in green. So x equals 6 would be right about here, and x equals 12 would be right about maybe there. Again, I know my drawing's not perfect. So really, that's our feasible region right there. That's the feasible region. So let me scroll up just so it's a little easier. Actually, no, I'll just do it right here. All we need to do now is find 1, 2. Here we actually do have 4 points, but I think we can probably guess that our maximum is going to come from one of those 2. The other ones are going to have zeros involved. But let's find all the vertices. So this one, let's see. That was x equals 6. So that's 6, 0. We can see we know the y coordinate is going to be 0 because it's on the x-axis. And similar to this one, this was at x equals 12. So it's 12, 0. Again, you just need to know that. You just need to know, yeah, that line was x equals 12. So where it hits the x-axis is going to be 12, 0. X value is 12, y value of 0. These ones, let's see. Well, we know the x values. This one's going to have an x value 12. This one, I need a little bit more space to show my work. This one's going to have an x value of 6. It's just a matter of what the y value is. And we could just plug it in, or we could use a calculator. Second, calculate value. X equals 6. Let's see what we get. 619. And if we plug in second calculate value, 12, enter, we get 1213. We could have done that by hand, and if you did, there's nothing wrong with that. I'm just showing that there's more than one way to get your answer. Now we just take these, plug them into the objective function, see what we get. I think we can pretty much say, okay, these two are not going to be part of our answer because they're involved with 0. And basically we see, okay, 619, that's automatically going to give us more than 60. Same thing with 1213 and 120. So I'm going to skip the bottom two vertices. So 619, let's plug that in. So 12 times 6 is 72. It's been a long day, I'm double checking myself. 12 times 6, yeah, 72. Plus 19, well, 19 times 10 is just 190. So 72 plus 190 is 262. Yep, 262. And then 1213, so 12 times 12, well, that's 144. That's not too bad. I do not like how crammed this work is getting. Let me do this in a different color so it stands out. I'll do this in green. So 12 times 12 is 144, plus 13 times 10 is 130, and I don't have enough space for this. Not my best board work ever, I'm ashamed to say. 130, and that's going to be 274. Yep, 274. And that is more than the other one. So that's our maximum amount. So what were they asking us for? How many hours a week should Stan spend in his job to earn the most money possible? Well, let's see. He should spend 12 hours at X and 13 at Y. I've forgotten which one was which. So 12 hours waiting tables and 13 hours mowing his neighbor's lawns. All right, so that's our answer to this one. Hopefully this all made sense. If you have any questions, let me know. Enjoy the rest of your day.